The data that I'm going to present you is real. Unfortunately, it's also anecdotal because I cannot quote the sources because the folks who want to, the source of the data wants to keep their identity private. Also, it's secondhand because this data was not collected by me, it was collected by Jason Gorman. But let me present it to you anyway, and you can assess whether or not it's appropriate. This is a case study of a fairly large company that began as a small internet startup and then grew. And of course, that's the hope of all internet startups. They want to grow and they want to succeed. Take a look at the graph on the left there. That's the amount of engineering staff, the number of programmers in the organization. And notice how it's growing at an exponential rate. The numbers on the bottom are the releases. So release 1 had, maybe 10 programmers, 20 programmers, something like that. By release 2, it had doubled, perhaps. By release 3, it had doubled again, and it continues to double, roughly, until by the release 8, they had 1,200 programmers. From 10 to 1,200 in 8 releases. Think of the amount of effort that implies. A tremendous amount of increased effort. Why? To get to the next release. What's going wrong there? The amount of effort applied to this application is growing exponentially, which tells you that the design and architecture are crap because the effort is growing through the roof. Take a look at the graph on the right, the blue one. That's the number of lines of code in thousands from one release to the next. And notice that it has the inverse relationship to the effort. The effort is an exponential scale. The number of lines of code is a logarithmic scale. The number of lines of code is not changing much. Even though there's 1,200 programmers, the amount of new lines of code are vanishingly small. If you're an accountant and you're thinking in terms of money, that would scare the hell out of you. If you're the CFO of this organization, that would look like a disaster in the making because you're spending immense amounts of money and you're getting almost no return. Take a look at the financial signature of the bottom. On the bottom, this is just the cost per line of code in programmer salary, and it's following the exponential curve. The cost per line of code is going through the roof. Something has gone wrong here. Now, what is it that went wrong? Well, it's an internet startup. And internet startups, do you think they follow any design and architecture rules? Or do they just kind of throw a bunch of code together and hope that something great happens? And in most cases, it's the latter. So the startup culture, especially in the United States and particularly in the West in general, the startup culture is a culture of making a mess as fast as you can in hopes that you can produce something that will put you on the exponential growth of profit. But this is a very bad strategy, even for an internet startup, because it forces most internet startups to experience this particular problem, and before they can ever get profitable, it kills the company. Most internet startups, especially software internet startups, fail not because they couldn't have succeeded commercially, but because they can't maintain and sustain the cost of the software they're producing. We all get excited about, Facebook or other internet startups that really made it big, but how many fail that you never hear of? And the numbers are astounding. Massive numbers of them fail. Would they have failed if they had kept their software clean? Some of them would have. Many probably would not, because they could sustain the effort long enough to grab onto the profit roller coaster. Some people worry that, we've got to be first. That's the only way to grab onto the profit roller coaster is to be first, and therefore it's justified that we make a mess early so that we can grab onto the profit roller coaster, and then we will be able to afford to clean up the mess later. Was Facebook first? Not by a long shot. Facebook wasn't first, Facebook wasn't second, Facebook wasn't third. There were a whole bunch of social networking companies out there. Facebook just happened to hit for some reason, and it's not exactly clear why. Whatever happened to MySpace? Was anybody on MySpace? Oh yeah, what happened? Just didn't hit. For some reason, didn't hit. They did something wrong, but it wasn't because they got there first. Facebook succeeded, not because they got there first. Continuing on with this, look at the productivity per release. The productivity per release, I arbitrarily set to 100% at release 1. By release 8, the productivity is on the floor. I told you about this yesterday, the decline in software productivity as the mess builds. Here's the actual measured evidence. And look at that fascinating curve, how it dives so rapidly and then bottoms out and asymptotically approaches zero. Once again, I stress, this is real data. And look at the cost per release in monthly payroll. If you're the CFO, and that's who that guy is there, well, it's not really him. I just found that picture online. But I think it probably assesses pretty well his attitude towards what's going on here. There's an old fable of the tortoise and the hare. It's one of Aesop's fables. And the fable goes this way. There's a rabbit, a hare, a rabbit, who can run fast, and a tortoise who goes slow, and they go into a race. And the rabbit is so confident that he can win the race because he's fast that he falls asleep, and the tortoise passes him and wins. And the moral of the story, of course, is that slow and steady wins the race. Have you ever heard that adage? Your grandmother probably told it to you. At least, I don't know what it is in Dutch, but in English, that's what it is. Slow and steady wins the race. One of the things that we face in the software community right now is this issue of the hare and the tortoise. Because everybody wants to be the hare, running as fast as they can to produce softwares as quickly as they can. And we hear the effort from our organizations. We have to go faster. We have to go faster. We have to go faster. And every software developer in the room has heard that message. We have to go faster. And you feel the pressure. You judge your self-worth by how fast you can go. That is not your self-worth. That is not your worth as a programmer. Speed is not your worth as a programmer. But we judge it that way. We think that way. That's how it's been impacted upon us for decades. Speed is everything. And so what happens because of that speed? Because of that need for speed, we become overconfident, like the hare. But what is the overconfidence? The overconfidence is not the confidence that we can go fast. The overconfidence is the confidence that we can deal with the mess. Okay, we're going to go fast, but we can deal with the mess, and we'll go back and we'll clean it up later. We'll deal with it. We'll deal with it somehow. We can deal with the mess because we need to go fast, and so we roar down the track, and we're going really fast, and we're making a mess, and the overconfidence is that we can deal with that. And what is the tortoise in this scenario? The tortoise is the mess. Because the mess builds slowly but inexorably. And eventually it will pass you and dominate everything about the project. Of course, we need to go fast. But how do you go fast? What's the secret to going fast? Is it typing faster? Is it thinking faster? What is the secret to going fast? The secret to going fast is to not build the roadblocks that are going to make you go slow. Because the roadblocks will make you go slow. So don't build them. You're a programmer. How fast can you go? Well, you have a speed. It's your speed. It's nobody else's speed. It's just yours. It's the speed of your thought, the speed of your ideas, the speed of your ability to conceptualize. Is there anything you can do to make that go faster? Can you rewire your brain to make yourself go faster? Well, yeah, there are some things you can do. Study, practice, but they're long-term things. They're not short-term things. If someone comes to you and says, I need you to go faster, what can you do? What can you do to go faster tomorrow? Nothing. Nothing. There's nothing you can do to go faster tomorrow. You might be able to go faster next year by learning something, by studying something. You might be able to go faster 5 years from now by practicing and developing skills, but there's nothing you can do to go faster tomorrow. So what's the key to speed? You cannot speed up. What is the key to speed? And the key to speed is not to slow down, not to build the stuff that's going to slow you down. So the key to going fast is to go well. Do the best job you can. Do the cleanest job you can. Make sure the track is nice and clear. Don't roar down and throw a mess down there. Build in a steady, consistent, clean way so that you can continue to go as fast as possible. Which, by the way, may not be very fast. But at least it's not going to slow down. We often have the impression that going clean is slow. And so we make the decision that temporarily we will go dirty because we can go faster by going dirty. Many, many people think that. In fact, there is a phrase in English, I don't know if you have it in Dutch, and the phrase in English is quick and dirty. Now, there's no such thing as quick and dirty, at least not in software. You cannot go fast by making a mess, even in the short term. And this is one of the debates we will have. Some folks will say, well, I understand that a mess will slow me down in the long term, but in the short term, I can go faster by making a mess. No, you can't. No, you can't. The mess will slow you down within an hour or two. How many of you have had the experience that you write code on your screen all morning long, you go to lunch, you come back from lunch, you look at your screen and said, who the hell wrote that crap? Because the mess will slow you down in a matter of an hour or two. If you are not clean, the mess builds and slows you down instantly. The graph that I'm showing here is from the same guy. Jason Gorman did this experiment, and I thought it was a good experiment. He wrote the same program 6 times in a row on 6 different days. The program he wrote was a program that he knew very well. It's an exercise that programmers often use as a way to practice. It is the conversion of an integer into Roman numerals. Try this one day. It's a fun little program to write. What he did is he wrote a set of acceptance tests that would demonstrate to him when he was done, prove when he was done. And then he set about to write that program 6 times in 6 different days. But on every other day, he used a discipline. On the even days, he did not use the discipline. On the odd days, he did use the discipline. The discipline was test-driven development. And you can see the results here. Now, notice the bottom of the graph, right? This is one of those statistical cheating mechanisms, right? I cut the bottom of the graph off at 22. So what we're talking about here, the differences here are relatively small, but I wanted to accentuate them, so I'm lying with statistics. With test-driven development, he was always faster. Notice that he's always getting faster during the entire exercise, right? Every day he does it a little bit faster than the day before. But with test-driven development, he was always faster than without test-driven development. And yet his experience was that test-driven development felt slower. And why did test-driven development feel slower? Well, any discipline feels slow. All disciplines feel slow because when you are exercising a discipline, you are stepping through the discipline one step at a time. All disciplines feel slow, but they speed you up if they're good disciplines. Test-driven development is a good discipline. Sped him up every time. Just felt slow. What is the solution to the executive's dilemma, the dilemma that the effort is building exponentially and the return is falling off logarithmically. What is the solution to this? And the only way to reverse the decline in a software project is to just be as clean as you possibly can. That all the developers and all the architects and all the designers follow the disciplines of software development and write the best code they can all the time. And the executives and the managers need to set that expectation. What do we, as managers, expect from programmers? We expect you to do a good job. And we trust that if you do a good job, you will be going as fast as possible. That is the expectation of management, and that is the behavior required of the software developers.